Hello all and welcome back. So in this video, let us now try to implement our stack using linked list. In the last few videos, we discussed how the same can be achieved. So please make sure that you see those videos once. In this now, we will be coding the full implementation. So let's get started. Now, this is the plain file I'm taking. So we will have to first create a node, the same node which we used in our linked list. In this, we will create a constructor and my constructor will take two things, right? Self.data, something which we know, and self.next. Great. So this is something which we have done already, everyone. This is just a node object, node class of which objects are used in our linked list. Now, the next thing which we have to do is stack using linked list, right? So this is the main thing which we have to implement, everyone. Again, please make sure that you are aware what are the different operations and everything. We are going to implement them one by one. Okay, great. So the very first thing, we have to create a constructor. When I create a constructor, maybe what I can do is I can just create a stack and it will be empty as of now. Okay, so I'm just saying that my stack this time will be a linked list. Last time, if you remember, this was a list or an array basically. This time it's a linked list and initially I'm taking it as empty. Great. Now what I'm doing, let's now implement functions one by one. Okay. So the very first which we have to do, and one thing more everyone, sorry, we have to create a size as well. So we forget this. Size should also be there, right? Size will tell us how many nodes, how many elements are there in our stack. Again, we are using linked list, but since we are understanding stack, we should be using all the terminologies, everything with respect to stack only. So don't talk in terms of node or anything. For the end user, even for us, this is just a stack. So I will be talking in terms of elements and not nodes. Okay, great. So this is the constructor as we have discussed about. We saw that how head and size will be the things which we will require. Now I am taking it as a stack. Okay, or maybe I can take it as head only because it will be better. As initially in this particular function, in this particular class, all the methods which I will implement, they will be using this head only. Okay, so for the outside user, he will have no idea whatsoever that if it's a overall stack linked list or an array, he will have no idea on this. But we will be making sure that we use the same. So the very first thing, everyone, is let's say push only. Push, we will get two things: self and data, right? The very first thing, once we get push, so let me make a stack side by side so we can talk and then discuss on this. Let's say this is my stack, everyone. When I add one to it, I'm going to create a node of one. If my head is none, then I will add that as a first node, something which we have already done. Else, I want to make sure that I'm able to add this as my head. So for that, what we will do, first, let us create a new node, which is equals to node with data. Now I have created this node in the memory, right? After that, what I will be doing, first I will check if self.head is none. If it is, then the work is easy. Just make it the head and return, right? Maybe what we can return, added, one second, f added data to the stack. Okay. So this is what I can return, everyone. Now this was the case when my linked list as of now is empty. But what if you try to add another element now? Let's say I want to add 2 now. If you want to now add 2 and linked list is not empty, we will have to make sure that we make a connection like this. So we have to just add on the head of our linked list, right? That is what we have discussed in the last video, that how this is the overall understanding we are going to do. So on that matter, what we have to do, else if this is not the case, new node dot next equals head. Okay. Not head, my bad. Self dot head, because we don't have anything as head, right? Self dot head and self dot head equals new node. So this time what I have done, I have said that, hey, first add yourself here and then please make me the head. Okay. So in this way we are able to do this, and we can just return the same thing here as well. Great. So of course, always we will be adding this particular node. So we should have no worries in this. In a way, we don't have to write else here, because if this gets into this particular code, this will return. So either of them only is going to get executed. Okay, great. One thing we have missed out, one thing which we have missed out, I think, which we should do in the starting only, self dot size plus equals 1. So this is very important to maintain size, right everyone? So I hope this all of you are able to understand why it is important. Great. Now what we are going to do, let us do top next. Okay. When talking about top, we will just be getting self. We don't need any data here. Again, if my self dot head is none, okay, or like I can add it or cannot, but I would like to add it so that there is a double check. If self dot size is 0, ideally we should not be requiring that, but to make sure that we never ever make a mistake, I am adding these both the checks. If we are handling our linked list properly for stack, we will never get this, but we will never get to execute this thing. But to make sure that in case I missed out on this, I'm still adding this as a check. Okay. Once we have our execution proper, maybe we can remove and check the same thing. Okay. Great. So if this is the case, we can just print, or maybe we can return this only. Return stack is empty. No top element. Okay, so I'm returning this. If we want, we can raise a error here as well. So we can raise some error as well. Okay, key error or something, index error maybe. So let us raise an error here as well. Okay, error is something which we can raise in Python. So should be fine. It is not as such required here, honestly. Okay, so let it be. We are just returning to let the overall end user know. Great. Because if I raise the error, then we will have to handle that as well. And we don't want to stop the whole flow, right? So we have to make sure that we handle the same as well. Great. If this is not the case, then I can just return self.head.data, right? Because if you see here, this is my top, which is in head.data. Great, everyone. So as of now, we have done 2 operations, push and top. Okay, great. Now let us do the next one, which is your and one thing more. Chalo, no worries. Let us do the next one, which is pop. Okay, so pop also I will get self only. This check will be there again. If self.head is none, cell.size 0, stack is empty, cannot pop element. Okay, so this is what we are going to do, everyone. If this is not the case, then first let us make data at top. It's going to be self.head.data, right? This is the data at top. Then we have to do self.head. So to pop, everyone, please pay attention what we have to do exactly. We have to make sure that I move this head to this particular thing. So self.head equals self.head.next, right? We just have to move it here, nothing else. That's what we have to do. Something which we have already seen. Delete at head. A simple O1 operation with just some commands. So let us do this. Self.head equals self.head.next. Since we have already checked that self.head is none, then we are going here. So no need to check here, because this will never be none. Even if it's a single node, then we will make our head as none, which will imply that we have emptied our linked list, right? One thing more which we should do, not to forget, size minus equals 1, right? So we have just subtracted the size. Once this is done, we can just return data at top. Okay. So cool, everyone. I hope each and every function as of now is clear. Now let me remove this. It's going to be a lot easy for the other two functions or the methods. So three operations which we have done are push, adding to our linked list, top, accessing the topmost element, adding to our stack, accessing the topmost element of our stack, pop, just removing the top element from my stack. Now the next is size, where I will just get self again, and I can just return self dot size. Okay, so size will have that information, and the last one is empty. Again, pretty easy stuff. This is the most easiest of them all. Self dot size equals 0. Each and everything we have achieved in a O1 complexity, because nowhere are we running a loop, nowhere do we have to traverse our linked list internally, and each and everything is pretty nicely done just because of a smart decision we make to add from our head. So we have to insert or delete from linked list head. Okay, so I hope you're able to see how good of implementation this is. Now let us check this, but for checking, what I'm going to do, we have to make sure that we are using the same code, and we will just check the output overall, because again the end user should not have no idea what exactly happened. Stack using linked list. Okay, so for end user this is still a stack. You should be able to enter here, you should be able to exit here as well. Okay, let me just change the name as well. Here is empty, so just a different convention. Yeah, great, everyone. So I will just repeat what I've done to check this overall working. What we are doing is we are taking the same code, because for the end user it doesn't matter, right? It doesn't matter for him what exactly is happening. He's just using a stack. If it is via list, if it is via linked list, it doesn't matter to the end user. Okay, great. Now let us try to run this, everyone. It's giving an error. Let us see. Print size it is calling. So return self dot size. Let us quickly check what is the issue here. It is saying int object is not callable. That self dot size we have defined altogether. Great, that is not an issue. Which is the function where it is calling, everyone? Let us see. Seems like the issue is here. Okay, so I think we have used this same. So one second, let us do one thing. What we can do is let us make it length, because else it is confusing. We are using size, which is an int object of this, right? So that is actually, I think, what is confusing. No worries. Dot size. No worries. Let us make it length, everyone. Okay. So to remove any confusion, and that's a good coding practice as well. Length. Yeah, I think this should be done. Great. So yeah, let us try to run this again, everyone. Again, it's giving an error. I think I missed it somewhere. Yeah. So where are we missed it? 34 line. Great. Now it seems fine. We are nowhere using this thing length. Yeah. Okay. Cool. So yes, if you will see this, everyone, now we are able to run the same. So is the stack empty? Initially, yes. Add 10, 20, 30, and 40 to my stack. Okay, they have been added. Is the stack empty now? No. Pop, the top element, 40 is popped. Pop, 30 is popped. Size is 2 and top is 20. Is it the same? Let us check. This is the overall understanding, right? True, push 10, push 20, push 30, push 40. So this is actually the implementation which we did in the using the list one, right? So we are going to see the same visualization. That is not a problem. But let us first compare the overall output. Is the output which we are getting from both the implementation same or not? Because that is also very important to check. Okay. So it's saying true here. Push 10 into stack, 20, 30, and 40. True. It has added, like just the language is different. Okay. Last is 40, 30, 2 and 10. 40, 30, 2 and 10. So it seems like it is working absolutely like the last stack which we created using list. And for an end user, that is very good because, of course, he doesn't care if it's a stack using a list or stack using a linked list. Okay, everyone. So I hope this was clear how we have implemented the same. Now, again, what I would like you to do is to take up some examples, try to draw the linked list along with your stack and see that how exactly things are happening. Okay, the same is going to be a lot helpful in understanding what exactly happened behind the scene, how using my linked list I was able to just make my stack, and each and every operation was also a lot optimized. So we are going to see the same visualization in the next video to make sure that each and everything is clear. Even if someone is understanding this for the first time, he gets that image in the head so that there is no problem in understanding any of the operation. Okay, so please make sure that you implement this at your end once as well, everyone. And we are going to meet in the next video.